Hello everybody and welcome. Today we'll be starting off a simple tutorial series, starting off with a portal frame. Exercise 1, portal frame and create. Yes. Now, we're going to start off by doing some basic changes like turning on intersection and nearest. These are very handy. Now once that's done, we're going to start putting down some, let's change the grid first. So for our grid line, I'm not going to be using the default. I'm going to say we've got about 4 bays at 5 meters each, and for the Y I'm going to say let's make 2 at 7.5 meters. I want my portal bay to be 50 meters wide. Now, since this is a center line, I'm just going to change the name from 2 to CL space, and this will give me 1 line, 2 line with a center line in the middle. Next thing I'm going to change is the heights, or the z-axis. Let's first create a view on these z-axis, nice from the front, and what we are going to be doing is simply take this and I'm going to say I want my columns to be about 5 meters high and the apex of my roof is going to be 5.7. Now, unlike your normal X and Y axes, Z-axis always work from the bottom or from the 0 plane. So this is going to be plus 0, plus 5 meters, and plus 7,500, 5,700. Now, as these are just names, I could have done anything like this. Just put 7.5 m, 5m, and it really wouldn't matter. Let's just modify them, close this up. Now, when you're starting off on Tekla, it gives you this 3D view to work from. You can get a direct view on your grid by simply pressing Ctrl P to get a direct top view. Let's just move this up there somewhere, and Ctrl P, get back to 3D. Also, you can hold Ctrl in and hold down your middle mouse button in order to rotate it around. Now, once we've set up our grid, we've got this outline going right around everything, and this is basically our world or our global axis, well, area limits. So we're going to say fit the area to the model, and that's going to make it smaller and fit it in here. This will just save us some trouble when doing drawings, and in a bunch of other cases become more apparent as you work. Now, once we've done this, we're going to write down some columns. Let's go to steel and select column. Now, you can either put in the column by clicking the intersection, as I said, handy, right here at the bottom, and then double clicking the column, or simply going here and changing the settings. This, of course, is this little icon that shows up every time. I've simply pinned it and kept it maximized so that it'll always be in the same spot, out of the way. Now, besides opening it from your column itself, you can also double click up here to get the settings. Whether you change the settings before or after you put the member in doesn't really matter. It's completely up to you. Now, for this item, I think I'm going to change the column do a 254 by 146, and as I said, the apex is, well, the top of the column at least is 5 meters. I'm just going to change this to 5,000, and I'm going to modify this. Now, any other column I put in will still be at 6,000 with the previous settings, unless I apply these settings. So let's apply them, and from now on these settings will be used in putting in a new column. Everything else I'm going to leave as is for now, and we've got these two. Now, once you've got your columns, I'm going to open up a view on grid line B. There are two basic ways to open up a view like this. We can either go select our grid lines, say create along the grid lines, and we create a view on each and every grid line. Quite a handy feature. If you do not have a view on the grid, you want maybe a view between two grids or somewhere specific, you can use view by 2 points. And this you do simply by picking any 2 points on this line, and depending on where you put your second point, it does change the direction you view it from. Then I'm going to open up the view properties either by double clicking, selecting the background and saying right click properties, and I'm going to change this depth to 500, and that's simply because I don't want to see the entire building, I just want to see the localized area, about 500 millimeters either way. Now that'll change this small area. Now next, Control P to get a nice front straight view, and from here we are going to put in the rafter. Now, as you can see, we've got everything set up with the grid, so using just the 2 points to get the rafter is very, very simple. But unfortunately, this is not always possible or practical. So, let's head on back to the 3D view. Go to Edit, Points, and we would like a point on line. Now, this command divides the line that I'm going to draw into a certain amount of points. One means just 1 point right in the middle. So the line is going to be the center top of that column, center top of this column, and it's going to give me a point right there in the middle. As you can see, perfectly center. Now, after we've got this point, close that up, I'm going to say right click, select it, right click, move special linear. And in this move special linear command, I can simply say, I said about 700 up, so 700 up. And now the point has moved to our apex position, 700 up. If you're not sure whether it's in the correct position, and even if you're sure, try to always double check your work. Go on to Edit, go to Measure, and pick the top point of your column, the top point there. It should give you a nice 7,500 and a 700. These are of course X, Y, and Z. If you look down here, X, Y, and Z, it's Y, and Z is up. Okay, that's the establishment of that. So let's go back to Steel, select Beam, let's edit the properties first. Now for the mark I'm going to use R, and for the name we're going to put in Rafter. Okay. As for the section size, let us select the profile and say 305 by 165 by 41. Again, these values will either be given to you by your engineer, manager, you'll retrieve them from your drawings, or if you're an engineer yourself, you will work out what size is needed. In this case, I have a rough idea of what I want, so I'm just going to use these for now. Click on the first point, click on the second point, and there you've got your rafter. I think I'm also going to change the rafter's color. Let's go up here and just make that nice color. Right. I'm going to get rid of that column over there. Just simply select it and delete it, as we do not want to currently use it. After that, go on and open up your connection and components menu, and we would like a base plate. If you know the number, that's the easiest way to get your desired connection. If you don't, simply type in the name that you want to use, and it should give you a few choices. Do note that the name Tekla thinks that it should be, and the name you might be used to or that you might use can be different. For example, a fin plate, Tekla does not know what that is, as it recognizes it as a shear connection or a shear plate. There are your shear plates. So be aware, if you've got different names for the same connection, you might have to try multiple of them. Okay, let's open up the base plate and go to parts. Now, this base plate is currently 20 millimeters thick. I would like it to be 16. So I'm going to type in 16 and make sure my base plate is highlighted and modify. Now, if you know what's going on with the connection, you can simply just make all the changes one time and get it over with. If you don't know what the settings do, then change one at a time and modify if possible. If your PC's processing power does allow you to do it that way, it's quite a good way to get used to what changes what. So I'm going to make both cross centers 200 and the edges at these sides I'm going to make 50 and 50, and I'm going to leave the edges at the top and bottom at 75. Note this little picture here of the cone. That direction indicates the cone direction here. So if I change there, the change will happen up here, as it is the direction the cone is pointing. Apart from these settings that I'm currently doing to the plate, I'm also going to make the hole a little bit smaller and just use a 4 tolerance on an M20, giving me a 24 hole. Let's modify this, and that should be everything. Now, since I would like to keep using this settings, I'm going to say apply before I close up my menu. This way, if I put it in again, I'll be using these same settings. Next, we are going to be putting in a haunch at the top, and we're going to use haunch 40. Here we go. Select both parts. Always select the main member first and then the secondary member. Think about it in order of construction. Before they put in the rafter, they will always put in the column, so the column goes first in your component selection order. Now, upon opening up the connection, we are simply going to be loading up the default connection for this rafter size. So 305, and we are going to be using, let's see, what's this? 146 wide. Therefore, we will be using a 70 cross centers. 305 with a 70 cross centers. G stands for gauge, and that'll always be your cross centers. Let's load this up and modify. Now, as you can see, this is black on mine. If you haven't yet, you can check out my video on view representation filter. I will leave a link below on how to do this. Now, what this basically tells me is I don't want to use capital letters as my part marks. I would want to use a lowercase, so I'm just going to change that to a lowercase m, and now it's no longer black. Next, I would kind of like a stiffener over here, so I'm going to go to parameters and let's see, beam stiffener. I'm simply going to put in the thickness and let the program sort out the rest. Modify, and that should be about it. Let's make or go to our direct view. Just have a quick click here, and I think for now everything else can just stay the way it is. Go head back to 3D and close, well, apply this and then close it up. Now that I've got the one side, I'm gonna mirror it over to get the other side. So simply select your two parts, either using a shift and or control in between selection. Shift means whatever you click, it'll just keep adding to your selection. Control, on the other hand, you can, if you pick the wrong item, pick it again and it will remove. So personally I find it more useful. Now, if you right click somewhere on the background after you're doing selection, do mind you don't have to select your components, they will automatically go with if all their parts are present. So right click on the background, go to copy special and mirror. Now for the mirror we would like to create a center line. If we simply Control P to get a nice top view, and we're going to make a center line from somewhere over here, and that'll take it and just flip it over to the other side. Copy. As you can see there, it's on the other side. Now this does not have to be done in a plan view. It really doesn't matter, as long as the line you are copying it, or the line you are using for your center, is on your grid lines view. So in other words, any line that's in the XY plane can be used, doesn't matter what the angle or where it is, but a line that goes in the Z direction will not function. Well, only goes in the Z direction, won't function. Just something to keep in mind for a later time. Now, once this is done, I'm going to go do the apex connection right over there. Now, for the apex connection, you can either use an apex haunch over here, but for this specific one, I'm going to be using a joining plate. I'm going to say join, and all this does is put some end plate on either side, connecting the two together. Again, I'm going to open up the connection and load up the 305 section size and modify. Again, I don't want a 20 plate, I would like a 16, but the rest of the connection settings I am going to leave as is for now. after the joining plate, I think we can just copy these rafters into the rest of the positions. So selecting all 4 items, right click somewhere and copy. Now copy generally works by selecting items, picking an origin and picking a new location. For my origin, I'm just going to stake somewhere along this grid line B. Doesn't really matter wherever the easiest for you. Next, for my destination point, I can just bring it over here until I get the perpendicular sign as well as the 5 meters so that I know it's correct. Put it down there, there, there. If you are unsure or you do not have 2 points to use, instead of using a normal copy, I would suggest using something like copy linear. Now with copy linear, after you open up the command, you can again pick 2 points. I'm just going to pick 2 random points, 1 on each line, and it will fill in these values, but it won't make the copy. Let's just interrupt this command. Now, this command is completely separate from the actual items, so you don't have to currently be busy with the command in order to use it. Let's go select these 4 items again, and now we would like to copy it, but only in the X amount, so we can go and either remove the Y or simply turn the Y off before we copy, and it'll make my copy in the X direction without doing this. Now let's move on to our purlins. Either go back to the newly created view or come up here to views, view list, and throw over really any one of these. It doesn't matter. I think C would probably be the best option for now. Go over to C. Now I'm going to close the view list. Right. As you can see, we've got a nice little center point right up there, and I'm going to put a point there to mark it. Let's say point at any position, and if you can't get it through a snap, simply select your rafter. If they're on the same point, they are correct. Then go at any position and put your snap right on that point. Gives you a nice little blue point. Next, you've got a variety of means in order to do the points. Now, one of them would be points along a line. So, a long extension of 2 points. So long extension of 2 points, let's say 250, apply, and wherever I put my second point down, from there 250 is going to put in a point. Now you can use this as a negative. Let's just undo. So put 2 point, put point right at the middle, and from there 250 down, it'll give us our next point. If we go and measure it, we'll see that. Now, personally, what I prefer to do is selecting the point, right click copy, picking it up right on the, and then using our nearest snap, which allows us to snap on a line. We can simply bring it out and type in 1200. Enter. And what this will do is give us our next point at 1002. I'm going to then select that point, pick the first point as my starting, and then just click on the last point every time. And that'll give us our next points. Another quite easy way to do this, once you've got the 2 points at the desired distance, is take the second point, use your linear copy to pick your 2 points, and this will give you the correct amount in both axes. Afterwards, select the point you would like to copy and simply say you want a certain amount of them. Copy. And this will give you a bunch of points. I'm not going to need those, but a bunch of points along this line. Again, you might just want to zoom into a couple of spots and make sure that the point is still on the top line of your rafter. If you did your angle slightly wrong when doing this, they will no longer be on the rafter and your roof will not be aligned properly. Next, I'm going to take this bottom point and delete it. Afterwards, I'm going to say point at any position again. I'm going to take right there, point. Afterwards, select it, and I'm going to copy it upwards by 300. Now, as you see, the further you zoom back, the higher the number it snaps according to. Just get it snapping into the tens. There, put down 300. Again, a good way to quickly do things. Do note that when you're doing this, be very careful that you are snapping on the line and not to another point in the vicinity, as it could cause problems. Now, once all of this has been done, I'm going to change my selection to only feature these points. And I'm going to do that by going down here, deselecting the point snap, clicking on it again, and now only my point snaps are selected. This means I can select anything and it'll only select the points. Let's go back to our isometric or to our 3D view, and this will allow us just to select those points. So what you want to do now is create a copy. You want to take these and have them at the middle, the start and the end, or every bay, depending on how you want to split your purlins. Now I'm going to be doing double bays, so one purlin is going to stretch over 2 bays. Let's head on back to steel. Now the main problem when doing something like a purlin is that, well, firstly, all our steel is aligned according to our global axes. Now what we can do, let's just turn our all snaps back on, is open up the item and enter an angle here in the rotation. But unfortunately, we do not know the exact angle of our roof. So the first thing we want to do here is make sure our global axis is set to the roof, so that when we put the item in, it'll automatically be aligned. And we will do this by heading over to View, selecting Work Plane, either the top icon over here, or just drop down, take the first tool. And as you can see, we've got a variety of selections, and we would want it to be directly on the top of the member. Next, I'm going to say put it in from there to about there, and just to make sure that it's perfectly aligned, I'm going to go over to C. Now I would like to see through this, so I'm going to say Control and 2, and this will make my view slightly transparent and allow me to see the member, and it does appear to be perfectly aligned. Let's go back to isometric. Next, you can do one of two things. You can either leave the item there to open it up and go change the settings, or you can simply start over and create a new one. Now, if you do go to the drop down menu over here, head on down to Perlin and load it, we will find our settings for our Perlin. As you can see, front 10, all the other settings, and I will explain them as we go along. Firstly, make sure that your material grade is S355JR as our standard material grade, or whatever standard material grade you need to use. Like a lot of these things, they kind of tend to have presets they define as what they think it should be, and that is not necessarily what you need. So, just going to select both of these. Right. As I said, double base, so put them in from the first to the third and the third to the fifth. Right on those points. Do make sure that when you're doing this, you are snapping to the point and not to the multitude of snaps around it. You want that nice big green square to know that it is a point snap. Right. From here, I'm going to go back to grid line C, and I'm going to have a look at this. Now, as I said earlier, they've got a 10 here. Basically, front is right at the top, and then 10. This 10 is for the cleat, so that it's got welding on the inside, and I'll show that when we get to it. Next, these marks that I'm using currently are not the center of the purlins, rather they are the back of the purlins. So I'm going to take one plane, I'm going to pick a side, it doesn't really matter which one of these two I pick. I'm simply going to pick one and modify. If it is not correct, I can simply pick the other one and modify it again. Now, these usually work via our axes. In the beginning, if you're not sure what each of these do, you can simply just change one of them, modify, and see what happens. Just take 8 on rotation. As we can see, it determines the angle of our member based off of our global axis. At depth, let's take behind, and that's the up-down direction. So this is our Z. Let's just put it on top of the rafter. Next, we've got on plane. As we saw when we moved it the first time, it'll be the X or the Y direction depending on the 2 points of your item. Now, once this is done, let's just close that down. I'm going to clear these settings and close this as well. Let's go back to our isometric view, and we would like a cold rolled overlap. Now, when it comes to cold rolled overlap connections or purlin connections, you will most likely have a couple dozen different connections that are exactly the same. Biggest difference with these are each one is named or made according to the main manufacturer of said cold rolled section, but they're all basically the same. So if you are using a specific manufacturer, you might want to use their specific connection setup, or you can just use the general one, which is 1 gold rolled overlap. Select our 2 points, confirm. Next, we would like to just look at it from behind, but using our global, you see this here, rotation point is not as conducive to our current needs, so we're going to press Ctrl R. This is going to allow us to select a point. Let's just pick somewhere there in the air, and now we've got a new point to rotate around. Okay. Once you're satisfied, open up the gold rolled connection. Again, it's either before or after, doesn't really matter. Just move this, say, about there. And for this specific one, I'm going to use an angle line. I've got a 150 tall purlin, the base one that we loaded. I didn't really worry about changing the size. You'll of course need to set the size according to your GA. Let's just go and say, for this I would like to use a 150 angle line, and using both a 70 cross centers and a 70 pitch. Let's load this and modify. As you can see, we've got our 2 bolts set at that distance, and I'm going to just select those 2. Here I would like to select both sides before confirming with middle mouse button. These ones are just the 2 items and confirm, 2 items and confirm. Afterwards, I'm going to get a nice little side view, select all of my components so that when I press modify, all of them will modify at the same time. Now let's go first have a look at C, and while we're busy with this, take a measurement. Now usually it's good practice to have your bolts over the center of the item. In other words, I would like to move them 5 more up so that it doesn't matter which way around they flip these purlins, they will still fit. I'm going to take a measurement down to the bottom at 45, and I would like it to actually be 50. So let's just take a new measurement, put it right here at the outside so I can still see what's going on. Lovely. Now to get rid of these, simply click on your background, right click and redraw view. It'll take away all of those measurements. But what it will also do is you will deselect your component, so you'll have to reselect it again in order to make new changes. As it currently is, I'm fairly happy with what I've got here. So I'm going to go back to isometric, just get a nice view, either do an area selection for all of them, or just holding in control, select them one by one before modifying to make sure they're all the same. Now, what I'd also like to do is head on over to picture and change the amount it overhangs by. I'm going to take the 350 and just reduce that to 300. Again, this is something that you will find on your drawings, and sometimes it needs to be a specific amount in order to serve the purpose imagined by the engineer or the architect. Afterwards, I'm going to select both of these members, then I'm going to go and copy, and I'm either going to take it from point to point on my 3D view, or I'm going to head over to grid C, make sure that I get the nice there, and copy it on down. Now we've got our entire row of purlins. The next thing I want to do is rectify a small mistake that I made doing this. Now, usually you want your purlins facing upwards, and this is so that when they do the installation they can simply lean the purlin up against the cleat and from there bolt it one at a time, instead of holding it there while they're doing the installation. So we want to turn these around, but we are not going to just delete them and re-put them in, and we're not going to do this with rotation either. That's usually a bad idea, especially with your drawings. So what we are going to do is we're going to swap handles by simply typing swap handles in here. Now select all of your purlins and double click swap handles. There we go. Now they've swapped around and facing the other direction. Once you've done that, just go through and make sure that all your connections are still fine. There's nothing that I can see that obviously broke, as sometimes things will break. The other thing that you have to be careful about is that swap handles only works on your axes. As we are currently using a flat area on top of the rafter, it is not a problem, but if we have switched back to the global ones, then our swap handles won't work as well. Simply demonstrated, you don't have to follow along with this one. If we go put our axes to our work plane, it's just using parallel to work plane, and we do a swap handle. Let's just go over to C, much easier to see, and use swap handles from here. As you can see, it's completely the wrong angle, and that is because we are using it based on our flat axes. As this is a rotation, it doesn't really work that well. So just remember that when doing it, always set your axes back to whatever the flat angle of the object is before you swap it around. Now, after doing the purlins, I'm going to put in some knee stays. Now, basically a knee stay is just a piece of angle line that will hit from the bottom of the rafter up to the purlin. If you open up the connection, head on over to stays, drop down, we've got them right over here, and that'll put them in. Now, what we would like to do is we want holes both at the top and the bottom. Again, we're trying to keep this as symmetrical as possible so they can flip this thing around and it will not matter. Next, we're going to go say, right, we measured it at 40. If you're not sure, just simply go back to the side view, go to edit, or press F. It is the shortcut. On measurement, take the bolt perpendicular up, bolt perpendicular down, so we know it's 40, and therefore we can just put in 40. And now our holes should be aligned. I'm just gonna these other ones as well. And I do this so that I can come here and see holes are perfectly aligned. Holes are perfectly aligned. Okay. Again, I don't completely trust the program, so, well, or myself for that matter, so I always try and double or triple check my work. Now, as for the size of the holes, size of the angle line, all that you'll usually, again, get from the engineer, or you can work it out. For this matter, I'm simply going to leave that as is. I'm going to make this an M1, P1. This is just the part mark and where the number series starts. That will always usually be 1 unless you're starting off at another number, but we'll get in depth to that later. Next, the item mark is KS for knee stay, and that's simply so that these marks over here are now done according to what I want them. Again, this will be determined by yourself or your company's preferences on how they want these marks and names to appear. Again, there's a lot of settings here we can change, but for now I'm just going to change those ones. I'm also going to do it at every second row, so the second row, fourth row and sixth row. Now, I would want the same at the ends, with the big difference being I don't want it to be going out both sides. So let's just take a end as it doesn't reach, and we're going to change this to be one side only. Incorrect side, let's pick the other one. That one seems to work well, and I'm just going to check, yep, all of them. This side I'm going to do the exact same thing. I'm just going to modify, it doesn't work, pick the other side, modify, it works. And that'll give me my knee stays on everything. Right, now once this is done, let's put in some bracings. A portal frame like this will always have a set of bracings on at least one of its bays, and these wind bracings and stabilization bracings are basically, well, therefore firstly stabilizing the thing during construction, and secondly if strong wind blows to keep the whole thing from toppling over. Now, firstly, what I'm going to do is I'm going to put in my eaves members. The eaves members are basically a beam, a pipe, anything in that order. That's something that I'll have to fix. That comes in right here at the top of the column, bottom of the rafter, between the two items. So, firstly, put that in from there to there. As you can see, I'm currently still on the rafter. Well, sorry, I'm still on the purlin, and that doesn't matter. I'll simply just open up one of them, select all of them, get to my properties, and from here I'm going to load the pipe. For this purpose, I think the 114 by 3mm pipe will work just fine. as I said previously, this is the mark and this is the name, so try not to swap them around. If we go down here at the bottom, you'll find that they are clashing, and this is not a problem. With an ES beam, the position is fairly unimportant, you could say. So we can move them down 100, 150, however they need to still be in the haunch area of connection, but not interfering with the connection. And that should be good. I'm also going to go back and have a look here. They seem to be clashing for some strange reason. So I'm just going to take it out and put it back in. Nope, that doesn't work. So what I'm going to do is I'm just going to get rid of this entire row. The reason it clashes has something to do with the haunch. So we would like to bypass that problem. Now, there's a couple of ways to do this, but we're going to take for the easiest method. Firstly, just close this up. We're going to get a section view right through the entire building. So head on over to View, Create View using 2 points, and as always, I don't want to start at the edges. Somewhere along should be fine, and that's just so that I can make sure I've got the correct direction. Next, I'm going to double click on my background to get to my view properties, and I'm simply going to throw in a couple more zeros, and this will show me my entire building. Then I'm going to fit work area just to make this smaller again. And let's see, yep, I've got the entire building. Go over to that, and what I'm going to do here is select one row of purlins that I know is correct. I'm going to take them and explode component. Now they are no longer components, which means I cannot open them and edit them as I would. These are now just simple parts as if I put them in by hand. After this, I'm just going to select everything, copy it from there right on over to here. Now, because it's not a component, I have to make sure that I am selecting everything. I can't just copy over the purlins as I normally would. But because it's not a component, it won't automatically adjust and connect to the haunch instead of the rafter as it should. So that's one way of bypassing a problem. Just deselect that. So be aware that you can explode and force the program to do what you want, but it does come with some upsides and downsides, like just about everything in life. The next problem that we will definitely have is these connections are going to end up being skew. And that's simply because I had completely forgot to adjust my axes when I put them in. So let's go to C. As you can see, not very straight. So what I'm going to do is head on over to work plane, drop down, go to parallel view plane, and just click anywhere on the background, doesn't really matter, and that'll reset our axes to the work plane. After this, I'm going to open up the pipe, select all of them, go to position, and just make sure that my angle is 0. Now, this is a pipe. You won't be able to tell the difference, but the program does have a set top, bottom, and sides in order to work its stuff out. So, even though it looks the same to you, be aware that the angle does have an impact on the pipe. Now, for the connection, what I'm going to do is just go over here and load up one of these eave strut connections. Eave strut connection is fairly simple. We've got a distance between our bolts. We've got a cross centers. Plate thickness, I'm going to use 10 instead of 12. And we've got a clearance of 1 mil each. Just change that to 2 and modify. And this will give us our connection. Now, unlike most of our beam connections, we are not working from top, we are working from the middle because this is a pipe. Easy way to see if a pipe connection is correct, simply take your recommended edge distance on your bolt size, M20, so this is about 35. Draw a construction circle from the center of the bolt, 35. Let's use Shift and 2, and this will make it transparent and allow us to see. Now, as you can see, that circle is going through the pipe, and what that means is too small. So let's go 170, 170, modify. We're going to go back to construction, draw a circle, 35, and that circle is no longer clashing with the. So we know that it fits, it is correct, and when they need to install it, there is enough room for the tool to get in there for the installation without having any significant problems. Now, we've got 90 cross centers, 170 10 pipes. Apply this connection, close it up, go back to isometric. That's good for that connection. We're going to put it on these, select your column, 2 pipes, confirm with the middle mouse, and just the same again. When it comes to the edges, let's change this to 170, and that should be all the changes. Okay, once these are done, let's do our roof bracing now. Vertical bracing should be the easiest, as we already have a view for it, so let's start with that and open up grid line 1, or make a view by 2 points along this grid line. Now, the bracing we are going to do is going to be between A and B, and we'll do the similar set between D and E. So firstly, head on over to steel and decide what type of bracing you would like to put in. I think for this example I'm going to do 2 different types of bracings. For the side I'll do a pipe, keep it the same size, and then for the roof I think I'll do an angle line, just so that we've got a bit of variation. So make sure that you've got direct view using Control P, so that we are on our plane. starting from the bottom on the outside, heading in to somewhere over here. Let's just use Control to see through everything. And that doesn't seem to be a point. So select your eaves beam. This gives us a nice little point to work from. Start from the bottom and we put it on over to that point. And this will ensure that our bracing is directly onto the eaves center. Let's close this up. Now, like we did with the eaves beam, we're not just going to leave this as a tube. We're going to put it on, well, either VB for vertical brace, or usually small buildings like this, I just do BR for bracing. And modify. Okay. Now, when it comes to the connection, we are going to be using a tube gusset, as this is a pipe, and the number of the connection is 20. So you can either search tube or just the number. As you can see from the picture, this connection is not only for the pipe but also for its square counterpart. And here at the top, we can't really put it onto the column because it goes right into this end plate, so we'll be putting it onto the pipe. So first thing we're going to fix is the one here at the bottom. Let's open that up, and we're going to change this amount. Now you can either just roughly estimate it or take a measurement and head on over to gusset and enter the value here. Now, although it does say 147, I'm just going to use 145, or I would use 150. And that's simply because working with a round number, much simpler, much better for everyone involved. If you can round the number down, do try. If precision is not that big of an issue, if for some reason you do need a high level of precision, then using the exact number is also fine, just takes a little bit more effort. Next, I'm going to use Shift 2 again to make this whole thing slightly transparent. For my distances, I'm saying this is an M20, so I would like to use 40, 70, 40 as recommended by my South African Steel Institute Red Book. Let's go to gusset. Yes, I want a 10 thick plate. Here are clearance. Just quickly check by using F. We've got 31. We can actually reduce this slightly, say maybe 10, because there we go, 20 clearance. Now, the reason that is not accurate, firstly, is because it's measuring its clearance from this side and not from the bottom side. So, because it's only using the one side, the amount that you use is not necessarily the amount that it is away from the steel or the closest clashing item. Secondly, it sees this as a square. In other words, whatever fictitious corner there would be over here, it's 10 from that, and not 10 from the cut corner that we're currently using. Next, we would like to get our gusset plate roughly centered, and we can do that by, well, one of two ways. We can simply move our pipe, or we can do a setting in position. Now, let's get a nice top view, and that we can do either by selecting our component and say creating default views on components. Let's close this. This shall give us 4 different views on our component. Let's take the top one for now, as well as it gives us a more clear view on where our welding is, as well as our weld symbols sizes. Now, if you don't want to use the views created, you can always go and create a view on 2 points, but then you'd most likely just have to change a setting like that beforehand. Now, on to making the change. As I said, you can simply just move it. Personally, I prefer doing this on my position settings, giving either a 10 or a -10. In this case 10 is fine, gives us nice and centered. Let's take this and make it see-through, and we can see our grid line right in the center of that gusset. Now, the benefit of using position over something like just moving it to 10 to get into the middle is that when you're doing a lot of stuff like trusses that needs to come out a certain distance, or even if you're doing floor bracings, using this setting allows you just to select everything, modify once, only that one setting, and you'll know they are all correct. Whereas if you've moved something, you're not always sure which ones you have or have not moved, and you'll need to check them individually. After doing or finishing the bottom one, I'm gonna double click on it to open it up. Thereafter I'm gonna go up to the top and just modify my settings. Let's use Control R to get a nice point so we can go have a look at it from another side. And just about everything is correct except this. Should be easier to see on the direct view. I simply like to go to my 3D and just check to make sure that everything is sort of close to correct. This just prevents me from making a mistake that cannot be picked up on a 2D view. So afterwards we've got to shorten up that, and as you can see there's quite a big space in here, 37. So I'm gonna reduce this 10, so -5, -10 I think would do. And if I measure that, it is over 16, so that's good. Even 0 would work fine, as long as your clearance is somewhere in the range of 16 to say about 30. That is good. After we've done that, I think I can close this view. Shouldn't be needing it anymore. And from here, take this and move it on over to the other side. Next, we would want to do the roof bracing, and after that we can just mirror everything over to that side. So for the roof bracing, I think I'm going to use an angle line. Select the rafter, right click, and I'm going to create a view on the top of the rafter. These views are always on the center of the item, in this case the rafter. The top, bottom, sides just refers to the direction that you view it from. Let's open up the vertical bracing, change this to RB, since we'll be doing a roof bracing. And if we go to our profile, close this up, we want a L profile, and I'm going to use a 80 by 10 angle line. For the purpose for angle line, I'm also going to be changing the color, as I don't want everything to be the same color. Let's say 6 would work well. Change this all to 6. Get that as our base setting. Next, I would like this to be a cross brace. There we go. Now, again, we've got a problem with the orientation. Since I'm doing something like a roof brace, I need to align it according to the roof. Now, last time I aligned it according to the part using the work plane tool. This time I'm going to align it to the background using the parallel to view plane. And the reason I can do this is because I'm using a view plane that is parallel to the roof. Select both of these and modify them, and we'll see them directly from the front. Now, as these are angle line bracings, I want them to be center according to the SOP. I'd also like them to be facing downwards. Let's see, back, solid, and you'll see they are both facing down. Next, I would like to move them up slightly, so I'm just going to go over to my C line. Does not have anything, so let's close that, open up either A or B, and this will allow us to see these from the side. As you can see, our point is in the center according to our axes. I would like to have them behind, right there. Now, the main problem here is normally I would put them back to back, but we have a kind of clash here with the knees. In this case, I'm going to take them and I'm going to move them up right against the top. If we look at the isometric, you'll see that this way they clear everything. Now, unfortunately, I can't leave them here, as the gusset plate will have to be on top of the rafter, which won't work, especially not because of these cleats. So we're going to lower it by 10, and this will allow us to put our gusset plate right up against the flange of this rafter. The other method would be to lower it this flange width plus 10 and to weld the gusset to the bottom of this flange. But I think in this case this would do just fine. Now, our normal gusset is gusset 11, bolted gusset 11, and the nice thing about this gusset connection is that it's fairly universal and useful for almost any type of bracing connection. I even use it for my welded bracings. Even though there is a separate connection for that, it does not really have all that many settings. So this one, with its multitude of settings, works quite well. Let's just pick 2 to start off from, and as you can see, it's nicely there on the edge, and I think from here on out I'm going to do this according to this top view. Firstly, because this is on the flange, it does not really clash with any steel there, and you can actually make that 0 as it is going underneath the flange. In fact, you can make it less than 0. It simply needs to clear the bolt. But I think I'm just gonna leave it right there for now. Next thing is, yours would probably have, I think, 10 here to make it stick out some. Now, I don't personally like that, so I made mine 0. If you've got a value in here, like 50, then yours might look like this. And because it's all on its own, we don't want it to have that corner, so we just take that out completely. Next, 40, 70, 40 again, according to our standard M20 spacings. And I think that should be it for the setting. Both sides bottom works. Here we are going to apply it to both of these. Do note that firstly, it doesn't matter what your settings here are, whatever your country standards are, you will obviously need to do it to the second and third bolt if you've got a second and a third, as we have in this occasion. Next, we've got a couple of settings over here, and this determines the shape of the component. Now, even though this is a perfectly straight connection, using the perfectly straight gusset does not work. Using the one-up of that does work. So, if your gusset makes funny shapes, you can always come here and play around with these settings until you find something that works for you. If nothing works for you, you can always explode and change manually. Go top and the top. Now, as you'd notice, I did make my SOPs according to the back of the purlins, and that's simply because I'm bracing the purlin specifically, as most roof braces would. So the SOPs does not necessarily have to be here at the edge. Usually they're either on the purlin's back like this, or they can just be somewhere in this vicinity. The positioning is not as rigid as it is with some of the other bracings. After this, we are going to split apart these centermost parts so that we've got two separate angle lines. Then we're going to take our bolted gusset, take our solid member in the middle, and apply the gusset to the two external parts. Now, because these parts are actually touching, we will need to bring our clearance back. Okay, next, you might have a standard distance or amount that you need to shape it with. Usually it's about 30 degrees. Just going to apply these settings and put it into the other side. The next thing that is not here but is quite commonly used is something called a locating hole, and that would basically be a bolt that it just comes right here in the center. Let's take these lines, and I can't see the lines. Doesn't matter. I'm going to go to 3D. Because my axes are still set to the roof plane, I can use move linear, pick 2 points, and only move it in the Z direction. There we go. Now, as I was saying, locating hole is specifically just that, locating hole. It's more used for the fabricator, as getting the correct position for welding this plate can sometimes be a little bit difficult. What we tend to do is just put an extra hole in both the plate as well as in the angle line member, and this allows us to more easily find the correct position. We'll just put the plate on, drop the bolt through, weld the plate in place, and whether the bolt stays there afterwards or not really doesn't matter, as it has already served its purpose by that point. Copy this over. Do note that when you're doing something like this, the center is not always the same on both these items, as their SOPs or distances are not equal to each other. This one's a little bit further from SOP to SOP, and we've also run into the small problem of, as soon as we split it, it threw out these connections. Let's just put them back. That should do. Right. We need another set of lines. Now, the reason I'm not putting it in on this view is simply because this view is a lot lower in level than the actual part. If you do put it in on that view, you'll find that the bolt that you put in right under here does not exactly go into the gusset, in which case, like we did with the lines, we will need to move it up by only the Z-axis. That should be it for bed bracing. Now, once all of this is done, I'm gonna select everything, and I do mean everything. After that, I'm going to deselect, holding in Control, clicking on the other items, everything that is not to do with, well, the side. Then copy, mirror it over, but that is not going to work. Firstly, I need to set my axis back to global, otherwise the mirror would be done over that angled axis and end up being in completely the wrong position. Once this is done, we will need to fully inspect our new area to make sure that it mirrored over properly, as Tekla sometimes tend to cause small problems when it concerns components and mirroring. Let's quickly have a look here. stuff like these two will need to go on that setting, and this setting will be over here, or simply open them up and swap this one around. Let's see. N seems to be correct. That seems to be correct. Bracing seems to be correct. These seem to be correct. Okay, and I think that should be about do it. I think I'll also take these two roof bracings and throw them over the center of the building. Mirror. So that they end up serving both sides. Draw view. That looks fairly nice, and I think that'll be the end of the first exercise. Thank you very much, and I hope you enjoyed it.